We have already worked on and experiment with examples of exponential equations where we have only one power on the one side of the equation, but on the other side we have a number. The example that you see on the screen is an example where we have 5 on the left side and 1 over 125 on the right side. Now, the beauty of this example is that it's simple, and it's simple because the 125 can be written as a power of 5. So we can find a way to rewrite the 1 over 125 as a power of 5. It's 5 to the negative 3. Sometimes though, this is not possible, and let's look at an example of an equation that this is not possible. Like for example, e to the negative 5x equals to 10. On the left side, my base is e. On the right side, my base is 10. And unfortunately, 10, there is no way that can be written as a power of e. And this creates some issues. And it creates some issues because somehow I need to bring the negative, I need to focus on the negative 5x that is on my exponent here. In order to work this type of equations, I'm going to use what I know about logarithms. And I know two different formulas for logarithms that they help me a lot. And the power rule. The power rule is very important for us because it says that whenever you have a number, any number, a to the n, then and you take the logarithm of this number, then this is going to be equal to n times the log with base a of the capital A here. So this is the power rule. And this rule basically what allows me is to bring the n down on the equation from the exponent down on the first level of the equation. So I'm going to use the logarithm. And how am I going to use it? Well, if I know, let's say that I have a number a that is equal to 3. If a is equal to 3, then this means that the a itself is the number 3. So if I have two quantities, left and right, that the one is equal to the other, then what I know is that the logs of those two quantities will also be equal. Okay? And since I know that, then immediately I can apply this to the equation that I start with. So if these two numbers, e to the negative 5x, is equal to 10, these two numbers are equal, then this means that their logarithms are going to be equal as well. I'm not going to take any logarithm, but I will take the ln. Why the ln? Because I'm focusing on my base here, and the base is e. So I will take the logarithm of both sides of the equation that has the base of the power. So I'm going to take the ln of e to the negative 5x equals to ln of 10. Is that true? Yes, again I said that if this quantity right here is equal to 10, then this means that the logarithm of this quantity will be equal to the logarithm of 10. Okay, so now I can apply the power rule. That tells me that if I have a power, the logarithm of a power, then this is equal to the exponent times the logarithm of the base. So this allows me to bring the 5x down. So the 5x now is going to go down here using the power rule. And I will have negative 5x times e times ln of e equals to ln of 10. Now, let's observe what happened here. First of all, the negative 5x is now on a variable and not at the exponent anymore. Second, by choosing ln, where the base of the logarithm is e, I managed to have now ln of e. And ln of v, since the base and the argument of the logarithm are the same, I know using the following rule of logarithms that this is equal to 1. So this means that this is equal to 1. So what do I have now? I have the following. Negative 5x times 1, that is negative 5x, is equal to ln of 10. Okay, so now it's easier to solve that for x. What I need to do is divide both sides of the equation by negative 5. And I simplify the negative 5's here, and I have x is equal to ln of 10 divided by negative 5. Now, one thing that I want you to be careful is that I divided the entire ln of 10 by negative 5. So the negative 5 is the denominator, and the numerator is ln of 10. The negative 5 is not in the argument of the logarithm, it's just the denominator itself. And this is the answer for this problem. Now, working problems with only one power on the one side of the equation like this, it's something very helpful. It's something that we many times work with, and always we want to change them by using logarithms, but logarithms that they have the base of the power. So we need to look more examples like that to make sure that we understand always how do we choose our logarithms. So let's work on another problem. And the problem that I will work with is not going to have e anymore. It's going to be a completely different one. So let's assume that I have 2 to the 5 minus 7x equals to 15. Again, I have a power on the one side, a number on the other. I need to first of all see if there is any way to write this number as a power of 2. Well, if it was 16, I could write it as 2 to the 4th, but I can't because it's 15. Okay, so the next step, the next thing that I can do is perform logarithms. Take the logarithms of both sides of the equation. What logarithms though do I take? What base do I use? This is important to remember. You take the base of the power. So, since the base of the power that you have is 2, you need to take the logarithm with base 2. Okay, so on the one side I will have log of 2 to the 5 minus 7x. On the other side I will have the log of base 2 of 15. And this is going to give me the next step, and the next step will be using the power rule. Why? Because I want to bring the 5 minus 7x down from the exponent. So now I have 5 minus 7x. Put it in parentheses. It is important to put this in parentheses if it is more than one term. It is important because otherwise when you multiply, you may forget and multiply only one of the terms of your exponent with a logarithm. So you have now this times log with base 2 of 2. So the beauty that I chose the base 2 right here is that this part of my equation will become equal to 1. And this is equal now to log with base 2 of 15. Nothing changes on the right side yet. As you can see, it stays as is. But if I simplify now, the left side of the equation is 5 minus 7x times 1, so it's 5 minus 7x, equals to the log with base 2 of 15. Now, I want you to remember that the log of 15 with base 2, it's just a number. I don't know exactly what number is, but I can tell you it is something less than 4. Why? Because 16, that is a little bit bigger than 15, is the logarithm of 16 with base 2 is 4. So the logarithm of 15 should be something like 3.8, something like that. So it's a number, remember that. So I have 5 minus 7x equals to this logarithm. You don't need to change it, you don't need to approximate it, but you need to remember that that's a number. And since it's a number, it's a constant. So now that you are asked to solve this linear equation, you're going to separate the variables, that is only this, from the constants, that is this one and this one. So I will leave the variable on this side and I will pass the constant on the other side. So I have log with base 2 of 15 minus 5. Remember, the argument of the logarithm is just the 15, what I had before. The entire number is going to be reduced by 5 here. And the next step of the equation is to divide both sides by negative 7. So I need to divide both sides by negative 7. And my result will be, I can simplify now negative 7 and negative 7. And I have x is equal to log with base 2 of 15, put it in parentheses so you don't get confused, minus 5 divided by negative 7. And that's your final result. Now, if you want to approximate that, as I said, this is almost 4. 4 minus 5 is going to be almost negative 1. Negative 1 divided by negative 7 will be almost 1/7. You don't need to do that, you don't need to approximate it, but it's a good idea to keep in mind that the logarithm of a number is just a number.